6 on permutations. Permutations, I want you to think of a key word. And the key word for permutation is to order or arrange things. Order or arrange. Now, how can you remember that? Well, here's my dumb joke for permutation. You go to some hair salon and you ask for your hair to get permed. They add a little too much curl to it and it's kind of freakish, and that's what I would call a permutation. Now, in that case, you can remember what they were trying to do with your hair was to arrange it. So the key words I want you to think of is ordering and arranging things with permutations. So let's start out with ordering, arranging something very small. 3 little objects, the set that contains the elements A, B, and C. How many ways to actually order or arrange them? Well, let's actually physically list them this time, but we won't take the time to list them in the future. We'll just calculate. So we have the choice ABC, we have the choice BAC, we have the choice CAB, we have the choice ACB, we've got the choice BCA, we have the choice CBA. And those are it. Those are the choices for our arrangements, each one being called a permutation. So again, a permutation is an ordered arrangement. Now maybe you can think of POA, P-O-A, permutation, order, arrangement. Whatever it takes to help you try to remember this, that's what we're looking for in a permutation, is an order or an arrangement. So all we want to do is determine the number of permutations of letters A, B, and C without listing them. And we can use what we learned yesterday, which was the fundamental counting principle in our previous lesson. Let's see if we can figure that out. There are 3 letters. We have 3 choices of placing those 3 letters. So for the first position, we can choose any one of the 3 letters A, B, or C. We have 3 choices. However, since we're not allowed to repeat letters, when we get to the second position, whatever letter we already chose, that means there's 2 remaining. And after we've used up 2 of the letters, in the third position, there's only 1 choice left. Fundamental counting principle that we learned in the previous lesson said it's a compound event. You multiply each outcome. So 3 times 2 times 1 is 6 arrangements, which we had previously listed, the 6. Now, when it's small like 6, we can list them, but when we get to numbers larger, like in the thousands, it's much more practical just to calculate how many there are, rather than actually list them all. So let's continue on this trend. Let's take 4 letters this time, P, Q, R, S. Let's find out how many ways we can arrange and order them, or how many permutations there are. Let's use the same fundamental counting principle we just did. In the first position, we haven't selected anything, so we've got all 4 of them to choose from. Could be any of the 4, P, Q, R, S. Whatever letter we choose, P, Q, R, S, we've used up 1 letter, so there's only 3 letters remaining for the second position. Now we've used 2 out of the 4 letters, so there's only 2 possibilities to choose from or arrange in the third position. And then in the last and final position, there's only 1 to choose from. So there are 4 outcomes for each event, but since it's a compound event, again, we multiply the results. 4 times 3 times 2 times 1 is 24. So there are 24 ordered arrangements or permutations of the letters P, Q, R, and S. Now, you might be noticing something we touched on a little earlier. We've got 3 times 2 times 1 and 4 times 3 times 2 times 1. If you take some number and multiply it by every integer less than that down to 1, that's called a factorial. So in this case, n factorial is going to be our answer. The number we're choosing, the number we're using is the same. If we have 4 objects, we're going to arrange all 4 of them. Then n factorial is going to give us our answer. Now, in certain situations, we are going to do slightly different things. What we've done so far is we've chosen all the letters available. Let's look at the word justice. We got 1, 2, 3, 4, 5, 6, 7 letters, but we're only going to choose to arrange 5 of them. Before we go on, let's just double check. Each letter in justice is different from every other letter in justice. There's no repetition. That's an important thing to notice. Alright, well in this case, for the first position, we could choose any one of those 7 letters. Once we've used any one of those 7, then we can choose any one of the 6. Then we can choose any one of the 5 remaining in our third position. Then we can use any one of the 4 remaining for our fourth position, and any one of the 3 remaining for our fifth position. So again, since it's a compound event, we're going to multiply 7 times 6 times 5 times 4 times 3, which when we do that on our calculators gives us 2,520. So that brings up a new idea, is sometimes we don't want to use all the letters that are available, or all the objects. So if we have n objects and we're going to use r of those, r being a smaller number than n, here is the formula we use to find the number of permutations. It's n factorial over n minus r factorial. Now, if you've got that button on your calculator, we will feel free to use it. But right now we're going to go through and work through a problem without the calculator for a second, so we can understand a little bit better, and then we'll use the shortcut and do the calculator. So let's say we've got 9 books. We're going to select 4 of those 9 and arrange them in some kind of ordered arrangement on a bookshelf. How many ways are possible? Well, that's 9, and we're permutating 4 of them. So the formula is 9 factorial over 9 minus 4 factorial. Now 9 minus 4 factorial is 5 factorial, which means 5 times 4 times 3 times 2 times 1. 9 factorial again means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And I know that in previous lessons we stopped at the 5 factorials, but today I decided to write them all out. Because any factors that are the same in the numerators and denominators will just divide out to 1. And we're left with our 9 times 8 times 7 times 6, just as if we had used the fundamental counting principle. So there are 3,024 ordered arrangements of taking 9 books, selecting 4, and then putting those 4 in some kind of ordered arrangement. If some of those items are the same, we have a slightly different formula. Slightly different formula. So let's look at another example. We've got the word hubbub, kind of a fun word to play with. So what we're going to do here is, in this case, we've got to see how many letters are the same. So we've got 6 letters, 2 U's, 3 B's. So we're going to use the formula where there's 6 letters to choose from. That's 6 factorial. And then we've got to put that over the number of letters that have repetition. So since the U's show up twice, that's over 2 factorial. The B's show up 3 times, that's over 3 factorial. And if we simplify that, that will give us our answer of how many ways to arrange the letters in the word hubbub, because not every letter is unique. Now, H is not being repeated, so that's included in part of the 6 original letters we're beginning with. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. Any factors the same in the numerator and denominator divide out to 1. So the 3's, the 2's, the 1's divide out. 4 divided by 2 is 2. That leaves me with 6 times 5 times 2. So there are 60 possible ways of arranging the letters in the word hubbub. Again, that's different from what we started with because there are some repetition of objects. We've got, again, the letter B showing up 3 times, the letter U showing up twice. Whereas we use the previous formula we just looked at a moment ago, is if there is no repetition, we've got 9 books selecting 4. 4 of those are not identical books. So that's the idea of a permutation. We can use our calculator to use that permutation button to figure out what our answers are, and we'll look at that momentarily.